Welcome all. This series about GitHub fundamentals and significance of GitHub in DevOps will be covered by myself, Sri, and Sabha. We both have a decade of IT infrastructure experience, and one will be gaining a foundation knowledge in DevOps by both theoretically as well as practical exposure. And in this particular video, we'll be covering an introduction to DevOps and an architectural walkthrough. We are going to share our experience, what we have practiced. Let's go into the content. So basically, the foundation for the DevOps is actually begin in 1967 itself in the form of Convoy's law. So this law is designed by a developer called Melvin. What's in short, what we understood, we want to share the way of what we understood. It's like any product, any digital product that is an outcome. It's an outcome. Basically, it reflects the quality of the communication which exists in the organization. So the communication structure reflects the product, right? So like, for example, if we have a beautiful car like Tesla, so it's a product, how the communication structure is laid out in the industry, in the company. So the same way the product reflects it. So better the communication structure, the better the product. That's the evaluation from this Convoy's law. So this has a direct impact in the organization in the product. So for example, if there is a small teams with fully skilled in a depth level of knowledge, and very clear communication that prevails in the team, and with open opinions being shared at any level, if that's the culture that's followed in an organization, in the particular team and the small team, and the product with a loosely coupled architecture defined, the best would be the digital product. So in short, we want to present the same here. Okay. Now coming to DevOps. So we would like to give an example to make this definition clear. So for example, if there is a product that's going to be developed by a set of developers, and it's going to be deployed, tested in lower environment, and then it want to be moved across to the higher environment like production. So here, if a small team with good knowledge of the development, coding of that application, plus how it's going to evolve and use to the end user's business, and how it's going to deploy to the infrastructure, what infrastructure it's going to be present for that particular application to be used by the end users. If this clarity prevails among the team, and the repetition, the frequency of this process of development, test, and deployment similar to the production, like a pre-production environment, happens more frequently, that is a minimum culture of a DevOps involving both people, process, and tools. So let's take an example. So here we would like to correlate with the car manufacturing. So in the traditional approach, if they want to make an improvement, like I am getting 42 miles per gallon in 2006. For a little bit of change, I have to wait for years to happen a small improvement in that area. And even, for example, it took almost 6 years to get a 2 miles more per gallon. This improvement took almost 6 years of time in the traditional way of development. If I don't follow a proper approach in like a kind of uh, micro level of segregation and loosely coupled architecture is not followed. So it may take, by following all the regular protocols, it will take like 6 years of time to achieve the same. For example, if I want to get the small change in the engine or in the body, I have to go for a lot of approvals, and I have to wait till this completes and next level of thing happens, like a sequential way of working. It takes a long time. But at the same thing, if using the modular design, like my goal is the increasing the miles per gallon, and I segregate each modules like drivetrain, chassis, suspension, and each team with good knowledge on each component works with only goal of reducing the miles per gallon. So they focus on each area. So the same improvement in 3 months of objective, even there was more 100 miles per gallon was achieved. So this is not something just we are telling as a story for this session. This is a proven fact. I have the reference here, which is mentioned here in the link below. So with a modular approach and right communication and right set of process and tools, not only software products, any products can be, its life will be better, right? So this makes, hope this makes small introduction with DevOps. So I will hand over to my friend Sabhabadi to continue.
Yeah, thank you, Shri. So, hi everyone. Hope everyone is doing good. Okay, so yeah, I just want to give some brief introduction about the DevOps architecture. So we have put up the architecture with the minimum standard tools that prevails in the market as of today. But these are all just the minimum standards. But yeah, like if you're feel free to add, you can do it. But just to get some context, like we have put up these tools here. So yeah, like one of the fundamental mindset of a DevOps engineer should be like everything as a code. So which means we need some central repositories to store all our codes or automation scripts, everything, right? So for that, we have selected GitHub as a source code management distributed version control tool, which is nothing but to store all the source codes in the GitHub repo. As you might know, GitHub is open source, and we can make use of those tools to store our source code information, right? When speaking about the source code information, it's not only limited to the teams who are developing the software mainly. It can be of any teams. It could be a database team or a QA team, or it could be also a DevOps engineer, infra admin team, even SRE and cloud security team. So they can write their own set of code or scripts, and they can make a revision of those scripts, and they can store in the GitHub repo, so that like whenever needed, they can switch back to the state wherever they wish, or they can make the continuous improvement process on the top of their codes, right? So that is where the distributed version control plays a very key role in the DevOps lifecycle. So once you check in the code, what happens next? Like we have to verify whether we have written the syntaxes properly and our codes are bug free, bug free kind of things, right? So for that, like we will be using some set of tools that is mostly a lint and scanning. Okay, so here we have put up some set of tools in as a workflow orchestrator, right? So once you check in the code, till it deploys to some instance, we will call that as a workflow orchestrator. It's kind of a completely automated or kind of a semi-automated way. That depends on the project needs. it differs from organization to organization, also differs from project to project. Okay. So once you check in the code, what happens next? It's linting and scanning. Once it is successful, then we used to do the code deployment. Code build, sorry. Code build could be using GitHub Actions or could be of Jenkins, right? And once you build the code, we want to store those artifacts that produced out of that build in a kind of a binary management system. Either it could be Artifactory, or in AWS we can use code artifact kind of things, right? So once you store the artifact, we can use those artifacts to deploy it to the environment. Uh, it could be either on-premise environment or it could be a cloud environment. But before we just deploy the artifact, we have to make sure some of the functional testing or unit testings are passing, right? Then we'll be in a kind of a more confidence way to deploy the code to whichever environment we planned. So this entire workflow constitutes the workflow orchestration, as I said. Also, we can use the secret manager kind of tools to store our secrets. Basically, in a DevOps world, we should not keep the secrets or certificates in a kind of a central repo. Instead, we should use some of the tools that are available, like AWS Secret Manager or HashiCorp Vault kind of tools to store all the secrets, right? So yeah, once we deploy to the instance, to either dev stage or production, so we have to make sure our latest code is working fine. How we can do that? Using the monitoring part, right? So we can use the monitoring tools to monitor whether all the features are working fine, and do we see any logs, any issues in the logs. So these can be monitored via log management tool, and it can be monitored from monitoring dashboard kind of things. And if something goes wrong, we can receive even alerts to our email or to mobile phone, right? So this constitutes the complete DevOps architecture. As we said earlier, these are all minimum set of tools, minimum set of standards. It could vary from um, time to time. Okay. So next we are going to see the DevOps mindset and the industry best practices. So this is the fundamental mindset that every DevOps engineer should have, everything as a code, minimal branching, immutable packaging, idempotent approach, logged and secure, and automation at a maximum. So we'll be seeing those each principle a little bit in detail below. Like everything is a code, as I said earlier. So we have to make everything, every changes, whatever we do on an instance should be in a kind of a coded way. For that, we can use the distributed version control tool uh, to store those source codes. Also, we have something like a kind of a pipeline as a code, right? So what does mean by pipeline as a code? For example, um, let's consider there are some two projects where some of the common functions are used in both the projects. So the ultimate goal should be we should apply dry. What does mean by dry? Dry is nothing but do not repeat yourself. So basically, we should not duplicate the codes. Instead, we should write once, and we have to utilize those. Either it could be a function or any classes. So wherever needed, we can call the functions inside our main block. So that is the main purpose of dry. So here, as we shown here, we have written some common module libraries and also some of the project specific libraries. So whenever needed, we can call those common module libraries inside the project specific modules. Okay. So we can write those common modules in a kind of a function or classes. We can call that function or classes inside the project specific modules. That is the main intention of pipeline as a code. So next mindset would be the minimal branching. Sorry, let's go to the infrastructure as a code. This also part of everything as a code. Uh, so here, what is our expectation? For example, let's say like you are going to spin a new EC2 instance with some instance type as t2.micro. Okay, so like this should be your desired state. Desired state is nothing but the state what you expected. Okay, it should be t2.micro. So whenever you use everything as a code, so the code takes care of like what kind of instance you want to be spin kind of things, right? So once you apply this code, the instant type will be spinned up with t2.micro. So there should not be any manual changes allowed or should not be done in any way. So in case if there are any manual changes, it's kind of a self-healing kind of thing. It automatically detects the change and revert the change to whatever the configuration we have mentioned in the code. For example, if someone attempts to change from T2 dot to some other instance type, so our code should be capable of detecting those change and revert that change to whatever mentioned in the configuration, right? So that's the main concept of infrastructure as a code. So this is just a kind of a basic information. Going forward, we'll be seeing those uh, going forward in the further sessions, right? We'll be seeing those concepts in detail. So next thing is the minimal branching, right? So in the a development phase, like we have a lot of branching concepts like long live branch, short live branch. So we'll be going to see in detail how we can manage those branching concepts. Okay, and then immutable packaging. So what does mean by immutable packaging? For example, whatever the package you built for the lower environment, it should be the same. It should be carried forward. The same package should be the same going forward for the higher environments like production or stage. Okay, so that speaks about the immutable packaging. What is mean by idempotent approach? Idempotent approach is something like there should not be any changes allowed, manual changes allowed. Instead, whatever the desired state we want to achieve, that should be consistent enough, like consistent in the entire deployment cycle. Okay, so yeah, that is about idempotent approach. Logged and secured, like once we deploy the code, we should see we should monitor the system, how the logging happens, and if something is going wrong, we should be informed accordingly. Also at the automation at the maximum, so we have to see the opportunities like wherever we can automate and create those automation wherever it is feasible, right? So this should be the DevOps engineer mindset. This is just a kind of a heads up. Maybe going in further sessions, we'll be seeing those principles in detail with some real-time example. So with that, yeah, I'm handing over to Shri to uh, go forward the further topics.
Thank you, Sabapati. So we'll be seeing more practical oriented, direct implementation level of examples and live sessions in the upcoming series. So with that information, we would like to give some gist of tool stack that and used for DevOps and how DevOps and compliance is correlated, right? So coming to the tool stack, like we Sabad explained about the architecture here. So we see the minimum set of common tools used to build a DevOps based architecture, right? So out of this, we have listed out uh, some of the highly utilized tools like GitHub for version control and GitHub Actions or GitLab CI for CI/CD orchestration, and Terraform or Vagrant for infrastructure as code. For example, we have listed a similar set for each category for security scanning, monitoring, logging, dashboard, cloud cost. So all these tools have been listed out, but depending on actual business needs and the environment, each tool will be suited. For example, if we have a big data applications running in Azure platform, we would recommend to go with Azure based CI/CD. And if you have like kind of a traditional tools, which is like more like some of the plugins dependent uh, architecture, and it's something which they don't need to do any further improvement or future progress. It's going to sit as a state. So then you can go with Jenkins. But the major set of pipelines in future will be in the YAML based CI/CD as code via GitHub Actions or GitLab CI is highly recommended. And we see a huge community base also lies in this area, and that's why we started this series with GitHub as the first set of series. All right. So coming to the compliance part. So for any listed company, there is to achieve a single true DevOps team to perform development, operation till production deployment. There are certain regulations that needs to be met. So that way, the frequent production changes will be a cakewalk. We cannot say a cakewalk, but it will happen in a more practical way. So to do that, to get the certification compliance, the DevOps is mutually helping the compliance, as well as compliance demands DevOps to be in a certain rightly planned way of DevOps implemented as we see in the architecture above. So for example, if there is a minimum need of controls to restrict the code review, to integrity of the package, and the desired state and the target state, how we are maintaining that, and also production preventive control as well as directive controls and the monitoring mechanisms. With this combination and the restriction controls, we can build highly auditable and detailed reporting architecture that will facilitate DevOps compliant environment, and that's something which is part of DevOps, the architecture that we are going to explore and recommend. So we'll be seeing more in detail. We would like to end this introduction to DevOps session with a real-time use case. All right. So during the pandemic situation, famous, highly operated and dependable, the country was dependent, UK was dependent on a national call center, and they were planning to make this call center employees to work remotely, but it was initially expected that it will take some 8 months or 9 months of time period, but due to the urgency, they want to do this in 3 weeks of time. So they adopted this model of taking small chunks of modules and segregating it and trying to achieve it in small pieces, and individually focusing on the problems on each goals. They were able to achieve the same in a very short period. For example, in the very first week, they have segregated a part of items that can be handled, which is non-sensitive, remotely. They segregated those centralized work environment to a distributed like remote workplace, and they started handling non-sensitive calls in the week 1. So which is something like a part of a production, which they released the production transformation, the transformation that they expected. They did it in the first week in a small phases, and the stage 2, to handle the sensitive information, they implemented the solution for recording, and that was also started handled in the second week, and from third week they were able to fix all the security holes and independently by focusing, and they were able to succeed. So instead of waiting for everything to happen in one shot and giving a long time, they adopted a fail fast mechanism and achieved their goals in small chunks. And this is something which is exactly we also want to show in the form of the same kind of mechanism which is adopted in the IT environment, IT product, like winning a small area and to see the production frequently, the changes happening in the production frequently, and that is being the process being cultivated across the team that enables with the right architecture, process, and people, this is possible. That's the true DevOps. So this session was, hope this gave you a small introduction about DevOps, and the upcoming series, upcoming sessions will be more practical oriented, and you will be seeing a live example, and you will be also preparing the live examples, like exercises will be there as a part of this sessions. Hope you understood. Thank you all.